Hello friends, welcome to our channel. In this video we will discuss delta modulation that we called as the DM. So let's get going. DM is basically 1 bit DPCM. DPCM is a differential pulse code modulation. So we called DM as the extension of the DPCM. Quantized level is given as L equal to 2 की power n. Because n value is 1, so we find the quantized level as 2. So in the DPCM we use only 2 quantized level. The basic concept behind the delta modulation is that approximated staircase version of the sample signal is compared with the original message signal, or we called it as the current sample value, and difference signal is produced, and we judge our signal according to the difference signal. What I mean to say is that XNTS is the sampled signal of X of t, and XCAP NTS is the last sample approximation of our message signal in the form of the staircase. And we compare both of these two values and the error will generate as ENTS, and we will judge the DM modulation according to this error function ENTS. After the comparison, if we find error function as positive, then quantizer give it as a plus del value, and if error function is negative, the quantizer give its value as minus del. That are the two quantized level that is used in the delta modulation, plus del and the minus del. Now we will try to understand whole mechanism with the help of this diagram. In this diagram, XNTS is our original sampled message signal, in which our amplitude is vary from 0 to 1 and then 1 to again 0. Let's suppose our current message signal value is 0.3 and the previous value is as 0.2. So this 0.3 is compared with the 0.2. So we subtract 0.3 from 0.2 and the resultant will be 0.1. So because this error function is positive, so the quantizer give it as a plus del value. Then again, as suppose our current value is 1, then the next previous sample value is 0.6. So we will compare these two sample and we subtract 1 from the 0.6. So the resultant is 0.4 as it is positive value. So quantizer give it as a plus del as our output. Let's suppose our next sample value is 0.2 and the previous sample value is 0.3. So we subtract 0.2 from the 0.3 and the resultant will be minus 0.1. This time our error function is negative, so encoder give it as a minus del value. So according to this error function, this will send to the encoder, and where the del is positive, encoder give it as a 1, and when our del is negative, encoder gives it as a 0. So the encoder output is transmitted by the DM transmitter to the receiver. So this sequence 1 1 1 1 1 0 0 0 0, in this case this will transmit from DM transmitter to the receiver. This is the basic block diagram of the DM transmitter, in which our message signal is passed through the low pass filter, then sampler, then the quantizer. Output of the quantizer is again sent as the feedback to this summation part, and the resultant will send to the encoder. This functioning is same as the DPCM, that is differential pulse code modulation. The basic difference between the delta modulation and the DPCM is that in the DPCM, the subtraction of the sample is directly transmitted to the encoder, as we subtract 0.3 from 0.2 and the resultant value is 0.1. This 0.1 is directly transmitted to the encoder, but instead of DPCM, in the delta modulation, the subtraction is changed into the del value according to its positive and the negative value, and then according to the quantized level, whether it is positive or negative, encoder judge the decider bit as 1 and 0. Output of the encoder is transmitted to the DM receiver, that is delta modulation receiver. This is the basic block diagram of the delta modulation receiver, in which first encoded signal is passed to the decoder, then we have a feedback mechanism, then low pass filter, and then we recover our original message signal back. DM receiver just perform the opposite mechanism of the DM transmitter, as in which we perform the subtraction, but in the DM receiver we perform the addition mechanism. To understand the functioning of the block diagram, please watch the video on the DPCM, that is differential pulse code modulation, in which I discuss the basic functioning of the block diagram in a very detailed manner. Now we will try to understand the functioning of the delta modulation when we have a general message signal. The purple color shows some random message signal. Then we perform the sample of this message signal. And by this staircase we shows the previous sampled value of the message signal. At this instant of time, the message signal is this value and the previous sampled value is this. As message signal is higher than the previous sampled value, so the error function will generate positive value, and as the positive error function, then the encoder generates 1 bit. At here we have a message signal at this instant and the error function at here. So the previous value is high as compared to the message signal, so error function generate the negative value. So we got the resultant as the 0 from the encoder. In this way, the output generated bit 1 and 0, these signal will transmit by the encoder to the receiver. One thing to remember in the delta modulation is that in the delta modulation we have a fixed step size, that is del. As delta modulation is 1 bit DPCM, so n value is 1 and the bandwidth is given by RB, that is nfs. So we are getting RB equal to fs, that is bit rate, because RB is a bit rate and fs we know that it is sampling rate. So in the delta modulation, bit rate is equal to the sampling rate. Second thing is the bandwidth. As we find RB equal to Fs, so in the delta modulation we require a low bandwidth as compared to the PCM, that is pulse code modulation and differential pulse code modulation, because in the PCM bandwidth is RB equal to nFs. As the n value increases, so the bandwidth of the PCM also increases. As we prove RB equal to Fs, RB is the bitrate that is related to the speed of the transmission. So if we compare the delta modulation with the PCM, in the PCM bitrate is given by nFs. So as the n value increases, PCM requires a high speed, as here PCM RB value is high as compared to the RB value of the DM, because in the delta modulation it's only depend on the Fs. So we require a high sampling rate in the delta modulation to match with the bitrate of the PCM. So Fs value should be high to maintain the high sampling rate. Quantization error is given as plus minus del by 2 and the del value is as Vmax minus V minimum by 2 की power n, and in the delta modulation n value is 1, so we find del as the Vmax minus V minimum by 2. So in the delta modulation there is no quantization error. Instead of quantization error, there are two types of new error in the delta modulation, that is slope overload error and the second one is the granular error. We will discuss both of these in the upcoming video.